Hello guys, in this video we're going to talk about the worksheet 10.2b level 2. It's actually two theorems, the equal chord equidistance from the center, and the second one is the chord equidistance from center are actually equal. So what's that mean? The first one, equal chords. So for example, if we have this chord AB is actually have the same length of CD, then which means that the distance from the CD to the center and the distance from the AB to the center, these two lines, ON and OM, are actually the same. So in this one, in the equal chord equidistant center, the first thing happened is the chords are the same. Then we can say that the distance to the center is the same as well. So as this thing that the equal chord, which means that the chords are actually equal first, then we can say that the distance from the chord to the center is actually the same. Okay, so bear in mind that there's a right angle in there because that's the shortest distance from the chord to the center. Okay, so for the second one, we have the chords equidistance from the center actually equal. So you can separate this two. So if you think about equidistance from the center, then the chords are equal. So first of all, we have the distance from the center to the chords are actually equal. These two lines are equal. Then we can say that these two chords are equal as well. Okay, so that's the two theorem that we want to learn. So bear in mind to remember this one. The first one is equal chord. First of all, you get the chords, the length are equal. Equal chords, equidistance from the center. And the second one, the distance from the center to the chords are the same. Then we can say that the chords equidistance from the center are equal. So in this two theorem, please bear in mind. Okay. So for 1a, we have PQ and QR are the chords of the circle. So we have PQ. So we have PQ and QR, they are the chords of the circle, and you can see that the length are the same, so that we can say equal chord, then equidistance from the center. So equal chord, then equidistance from the center. Okay, so which means that this OM is actually the same of ON. So A is basically just 4. Okay, so for part B, we have MN and PQ are chords of the circle. You can see that's the MN and PQ that are the chords. But in this time, they're actually saying that the OX is equal to OY, OX equal to OY. And then you can see that there's a right angle here, so that these two lengths are the same. And we have the PY is equal to QY. And they're now asking about what's the length of MN. So as the distance from the center to the chords are actually equal, so that these two lengths are actually the same. By using the chords are equidistance from center are equal. So we can say that the PQ is actually equal to NN. And we have the PY is equal to PY, which is equal to 14, so that NN is equal to double the 14, give you 28. So for question C, we have APB, CQD, POQ are straight lines, and we have the AB is equal to CD, so we have the same chord. So we highlight it first, AB equal to CD, which means that equal chord, then which means equidistance from the center. Right again, equal chord, then we have the equidistance from center. So which means that we have the QO is equal to OB. And they said that OB is equal to ACM, so that the QO is equal to ACM as well. So the X is going to be 8 times 2, give you 16. So for next one, we have AMB, AOD, CND, MON are actually the strict lines. And then in this one, we're going to calculate what is Y. So as you can see that the MO and the ON are the same, which means that the chords equidistance from the center are actually equal, which means the CD and the AB are actually the same. So we have the AB is equal to CD equal to 24. And now we can say that as these two angles are the same, which means that these two angles are the same as well, which means that these two angles should be the same as well by using the interior angle, isn't it? So that if this is the right angle, which means that this two, the length of this two, AM is actually equal to MB, we can using the theorem that we learned before, the line from the center perpendicular chord is actually bisecting the chord. So now as AM is perpendicular to MN, so that AM is equal to MB, which means that Y should be the half of 24 cm, give you 12 cm. Okay, so that's for question 1. You don't need to write down the answer, just give me, you don't need to write down reasons, just give me the answer as a revision exercise, and that's fine. So now we're going to do the question 2. That's the full explain question, so you need to give me the answers. So please remember how to memorize the theorem you learned before. For example, the line from center perpendicular to chord bisect the chord, and also there's one calling as the line joining center to midpoint of the chord is perpendicular to the chord as well. So all of the theories you need to remember them properly, then you can apply them in your exam. Alright, so for question 2, in the figure we have AB is equal to BC. AB is equal to BC, so write down that here. We have BC equal to 60 as well. And then we have the OM is perpendicular to AB. There's a right angle here. ON is perpendicular to BC as well. And now we have the AB is equal to 16. And if the radius of the circle is 10 cm, which means that OB, if you join OB, then OB is the radius, which is going to be 10 cm. So OB is actually 10 cm. That's the radius. And the question is asking you to find out what is ON. So I will highlight it as the yellow. So now how can we do this? So first of all, we got the OB is 10 cm. And then as we said, these two chords have the same length, which means that equal chord, then equidistant from the center, which means that MO and the ON are actually the same. So if you want to find out ON, it's actually find out OM is actually okay as well. So we can say that as the AB is equal to BC, so that we have the OM is equal to ON by using the equal chord. Then we have the equidistant from center. So now we have OM is actually equal to ON as well. So if you want to find out what is OM, then actually what we need is the length of MB. So as OM is perpendicular to MB, which means that AM is equal to MB, by using the line from center perpendicular to the chord, is going to be bisecting the chord. So we can have as the OM is perpendicular to AB, so that we have the AM is equal to MB by using the line from center perpendicular to the chord is gonna be bisect the chord. Okay, so now we have AM is equal to MB, which means that each of them is equal to 8 cm, the half of 16, so give you 8 cm. So if you consider about the triangle of OMB, then we can draw that out. This is O, this is M, this is B. So OM is actually equal to something we don't know. That's the required thing. And OB is equal to 10, isn't it? The radius. And then the MB is actually equal to 8, the half of 16. So OMB is actually right angle, so we can use Pythagoras. So OM is actually equal to 10 squared minus 8 squared, and taking the square root will give you 6. So as OM is equal to ON, so that we can say the required length ON is equal to 6 cm. So for question 3, in the figure, AQ is a diameter. So we have AQ is a diameter. So if the question is saying that we have a diameter, so probably we need to use saying the angle in semicircle, isn't it? So and we have the AB is perpendicular to ON, and we have OM perpendicular to BQ, and we have OM is equal to ON, so that the AB is equal to 22, BQ is equal to 24, and asking you to find out what is PQ. So for these questions, it's kind of quite easy. You may definitely know that you see OM is equal to ON, then you may just say that PQ is equal to BQ. But it's actually wrong, because they didn't say that this is a right angle. So this may not be the shortest distance from the center to the chord BQ. So we actually need to first of all prove that this is a right angle as well. So how can we prove it? If you look from here, AQ is the diameter, so that the angle ABQ is going to be the semicircle angle on the semicircle, which is going to be 90 degrees. So we can say the angle of ABQ is equal to 90 degrees. by using the angle in the semicircle. And then so that as this is equal to right angle, we have the angle of ONQ is equal to right angle as well, because we got two parallel lines, then this is the corresponding angle. So we can say that the angle of ONQ is equal to angle of ABQ is equal to 90 degrees by using the corresponding angle AB perpendicular to ON. So that's for ONQ is equal to 90 degrees. So as ONQ is equal to 90 degrees, then we can show that the shortest distance from the chord BQ to O is going to be ON. Then we can say that as the ON is equal to ON, so that we have the PQ is actually equal to BQ. So as again, the distance from the center to the chord are equal, so that the chords actually are equal as well. So we can say that by using the theorem of the chord equidistance from center are equal. Okay, so that's for this one. And then as PQ equal to BQ, so that the BQ is equal to 24 cm. Not that hard, but I'm just like a trap. When you see that the ON is equal to OM, then you instantly saying that BQ is equal to PQ, then you got 0 marks because it didn't prove that OMQ is a right angle. Okay, so for last questions, in the figure, two equal parallel chords, we have A, B, and C. They are equal, and then they are 10 cm apart. If the radius of the circle is 6 cm, find out the length of AB. So how can we do this? We need to find out the length of AB, and we got the radius is equal to 6. So we try to length something by saying that length of O and B. So first of all, you can join OB, so that the OB is equal to 6 cm, because that is the radius. So we have two chords are actually the same, so that the distance from the chord to the center are actually the same as well, but we need to make sure that there's a right angle. Okay, so we need to draw something. So for example, we draw a line from this point, the midpoint, from M to O. So we let this is the M, and we say that is the foot of perpendicular. So foot of perpendicular means that we extend a point from the center to the chord AB, and then the foot of perpendicular M is actually saying that the AB is going to be perpendicular to OM. And we do the similar thing from the O to CD, saying that this is the foot of perpendicular of CD, that is N. So we can say that we let M and N be the foot of perpendicular on AB and CD respectively. Okay, so now we have the OM is perpendicular to AB. Similarly, we have the ON is perpendicular to CD as well. And as we say that the OM is perpendicular to AB, then we can say that the M is actually the AM is actually equal to BM as well. So that we can say the AM is equal to BM by using the line from center perpendicular to chord is going to be bisect chord. And then we have similarly we have the CN is equal to DN as well. So now we can say that this is equal to the AM is equal to BM. They are the same thing. So if you calculate the length of BM, then we can calculate the length of AM. And then you see from here, as the O is the midpoint, so it's actually the same thing. So OM is actually equal to ON by using the chords are the same. So the distance from the chords to the center are the same as well. So first of all, you can write down as the AB is equal to CD, so that we have the OM is equal to ON, which is going to be equal to 10 divided by 2, give you 5 cm. The reason for that is the equal chord, then it's going to be equidistant from the center. So now we have the NO is equal to 5, and then the OB is equal to 6. Then how can we calculate the MB? I just write it here. So that the MB is going to be equal to the 6 squared minus 5 squared, and taking the square root by using the Pythagoras theorem, then the MB is actually equal to square root 11, so that we have the AB is equal to double of MB is going to be equal to 2 square root 11. So that's for question 4. It's quite hard you need to think a lot of things, and you need to bear in mind that which lengths are the same and when can we using the line from center perpendicular to chord is actually bisecting the chord. When you actually see a perpendicular, then you can say that they are bisecting each other. And then you need to draw several lines by yourself, so that's the harder point of these questions. So if you have any more questions, don't hesitate to ask me in the